What's up, everybody? Tonight we are debating evolution, and we're getting started right now. All right, everybody, we have a really interesting debate tonight. Thank you so much for showing up, everybody that's here. We have Standing for Truth and David Neff. It's going to be quite an interesting discussion. I know I'm interested in this topic. There's been a lot of debates on this, but we're going to be talking about universal common ancestry versus separate ancestry. So that'll be an interesting segment of this argument. So I guess what we're going to do is we have a format of 12-minute openings. We're going to start with David, and basically I just want to let everybody know, like, hey, if you're like, I really like this guy, well, their description, in the description, that's where you'll find their information. You can click on their links and find their channels. All right, and I just want to make sure everybody knows as well that this is an unbiased channel. We like to make sure that everybody feels welcome here, and but just try to keep it clean in the live chat there. We know how it can get heated, but we'll be watching it for questions as well. So just tag at Modern-DayDebate, and that's how we'll get your questions. So with that, we'll go ahead and get started with David for his 12-minute opening.
All right, thank you so much. Thank you, Standing for Truth, for agreeing to debate me, and thank you so much for Modern-DayDebate for hosting, and for Converse. Thank you so much for being the moderator for tonight. This is my fifth live debate, so I'm still a little bit new to the voice debate format. I debated Praise I Am That I Am that a few months back, which went really well. So tonight's debate is evolution versus creation. And what I'm going to be doing tonight is dividing my arguments into two parts. And the first part, I'm going to be giving an overview of evolution and the evidence for it. And in the second part of my arguments, I will be giving an argument for why creationism is not viable. The theory of evolution is one of the most misunderstood theories in science, yet it is also the backbone of modern biology. Nothing in biology makes sense except in the light of evolution. The theory of evolution explains not only the diversity of life, but it is vitally important in fields such as medicine and technology. Contention number 1, evolution by natural selection is an observable fact. Subpoint A, microevolution. We have observed evolution by natural selection both in the lab and in nature. When we expose bacteria to antibiotics, the chance mutations enables them to form resistance to the antibiotics, causing them to become stronger. The end result is bacteria with the favorable traits necessary to resist antibiotics, resulting in deadlier diseases. This is well known as microevolution, or the change in the allele frequencies in the gene pool. This is so well observed and documented that no creationist will deny this. Subpoint B, macroevolution. Speciation is the emergence of new species from a single ancestral species. This is probably the most important prediction of evolution. If evolution were true, then we should observe the formation of new species. As it turns out, speciation has been observed so many times that even creationists accept it, although they try to rationalize it by denying that speciation perfectly fits the definition of evolution, or by simply moving the goalpost. In fact, we even have different names in for how various modes of speciation happens. You can think of speciation like language. As time goes on, new words are added, people spread out, words change meaning, and thus new languages are formed. This is how Latin turned into Spanish, French, Italian, Romanian, and the rest of the Romance languages from a single ancestral language. You can think of the minor changes in pronunciation and meaning to be the quote-unquote microevolution, and the emergence of new languages as macroevolution. Contention number 2, genetics. Genetic comparison. In my opinion, genetics offers the most profound case for evolution. The closer related a species is, the more genetic material they will have in common. Using genetic markers, we can trace with stupendous accuracy on how humans and other species migrated. When I got my DNA sequence from Ancestry.com, I was shocked to see just how accurate it was. Not only were they able to tell the region of Europe where I descend from, they were also able to pinpoint exactly where my family settled in the United States, and they were able to tell when they came. We can use this to trace human ancestry back to when humanity first evolved. Using mcDNA and using yDNA, we were able to find that humans originated in Africa roughly 200,000 years ago. Using the same principle that determines paternity, we were able to find that humans and chimps are about 95 to 99% similar, which suggests that the two species are closely related. What is more is that we can determine roughly when humans and chimps diverged, which is about 7 to 8 million years ago. Of course, as more information becomes available and more studies are done, the more refined the date will become. Now let's look at a real-world example: HIV and SIV. In the 1980s, people were dying left and right of HIV. Where did it come from and how did it evolve? Let's find out. There are actually two main types of HIV: HIV-1, which is the most common, and HIV-2, which is less common. Using genetics, we found that HIV evolved from SIV, a virus that infects non-human primates. Most likely, humans were butchering meat from an infected animal, and that is how they initially came in contact. But there's a problem. Humans are naturally immune to SIV, so something had to happen. In his book, Evolving the Human Effects and Why It Matters, Dr. Fairbanks shows exactly how this happened. The virus had to mutate into a form that could overcome natural immunity to SIV in humans. Mammals have a gene that encodes a protein called tetherin. This protein has evolved to confer resistance to the retroviruses by tethering them to the inside of the cell they infect and preventing the viruses from replicating. For SIV-CPZ to successfully infect a human, it had to overcome the suppressive effect of human tetherin. The SIV-CPZ evolved by acquiring two anti-tether genes called NEF and VPU, one from each of the original monkey viruses that fused to form the chimpanzee virus. The NEF gene mutated to overcome the chimpanzee tetherin, but the VPU gene remained essentially insert. When the virus jumped from humans to humans, human tetherin was so different that the NEF gene could not overcome human tetherin. Instead, the VPU gene mutated to overcome human tetherin, allowing HIV-1 group M to infect humans. A mutation in a second gene called GAG was required for the chimpanzee virus to jump to humans. Interestingly, a case in which HIV infected a chimp is known, and the GAG gene of this virus mutated back to the original form in the chimpanzee to successfully reinfect its ancestral host. Subpoint B is ERVs, endogenous retroviruses. Endogenous retroviruses are viruses that incorporate themselves into our DNA. As I already pointed out, humans, bonobos, chimps are about 95 to 99% similar. This strongly suggests that we are closely related and share a common ancestor. When we compare genetics, we can look at ERVs and use that to help connect the dots. As it turns out, humans and chimps have thousands of ERVs in common. So either ERVs independently inserted themselves into the same location thousands of times, or we share a common ancestor who had it. The latter is far more likely. Now let's look at the fossil record. Subpoint A is the geological column. The geological column fits perfectly within the evolutionary framework. We never find a fossilized rabbit in the Precambrian layer, and we never find a dinosaur fossil on top of a human fossil. Subpoint B, transitional fossils. Where are the transitional fossils? I'm glad you asked. Let's just look at one example, the Archaeopteryx. Archaeopteryx is probably the first transitional species found. It was only found years after Darwin published The Origin of the Species. As noted by 12.origins, it has both bird and dinosaur-like feathers that are hard to explain away. The main bird traits being a long external nostril, and the two bald bones nuts sutured together, all teeth lacking serrations, large lateral furrows in top of the rear body of the vertebrate. Major reptilians being no bills, teeth on the premaxilla and maxilla bones, nasal openings far forward, etc., and over 100 differences from birds. And now part 2 is the failure of creationism. Let's identify 3 major predictions that the Bible makes in the first 5 chapters of Genesis. In the first chapter of Genesis, the Bible predicts the order in which the universe was created. The second key prediction is the age of the universe, and the third key prediction is how long humans once lived. If any one of these 3 are shown to be false, then the entire Genesis creation myth collapses. The order of creation. In the Genesis creation myth, God creates the universe in 6 days. On day 1, he creates the light and darkness. On day 2, he creates the sky and sea. On day 3, vegetation and land. Day 4, the stars, the sun, and the moon. Day 5, the sea, animal, and birds. And day 6, land, animals, and humans. The order that the book of Genesis proposes is inconsistent with what we know in science. How can a day and night exist before the sun? How can vegetation survive without the sun? Without the sun, the Earth would have been at or just above absolute zero. Modern astronomy has witnessed the life cycle of stars in solar systems. The way solar systems form is nothing like how it is described in the Bible. Stars form when clouds of gas collapse under its gravity. This is called a protostar. When the star heats up enough, it begins nuclear fusion. That's when it's fully a star. Not only have we observed this process, but we have found young stars with planetary disks around them. Even more impressive is that we have discovered moons swarming around new exoplanets. Solar system formation is nothing like what is described in the Bible. Next, the age of the universe. Creationists argue that the entire universe is less than 6,000 years old. A wealth of independent lines of evidence proves that the universe is billions of years old. Here, let's just give two evidence. The distance relates problem. Light travels at a speed of 299,792 kilometers per second. If an object is 1 light year away, it follows that the light from that object must have taken 1 year to reach the observer. The furthest distance we have seen is roughly about 13 billion light years away. Logically, it follows that the light took 13 billion years to reach us. Thus, the universe has to be at least 13 billion years old. Radiometric dating. Radiometric dating is the most accurate way to tell the age of an object. We can test the accuracy of radiometric dating by cross-dating it with various isotopes, as well as testing it with the age of known objects. This is incredibly useful in archaeology. For example, researchers found an old Quran that dates back to the time of Muhammad. When we applied these techniques to rocks and asteroids, we discovered that the Earth is approximately 4.6 billion years old, a far cry from 6,000 years old. And lastly, let's look at the lifespan of humans. As of today, the oldest person alive is 116 years old. However, in the Bible, the oldest person to die was Methuselah at 969. There is not a shred of evidence to suggest that humans once lived that long, and all evidence points to the contrary. From what we know, life expectancy from the Paleolithic era up to modern early England was less than 40 years old. So in summary, the major predictions made in the book of Genesis are a complete failure. The theory of evolution has been vindicated time and time again, whereas creationism can't even get off the ground. If you can't trust what was written in the very first chapter of the Bible, then you can't trust what was written in the rest. Thank you, and I look forward to Standing's reply.
All right, thanks so much for that opening statement. Now we'll kick it over to Standing for Truth for 12 minutes. Standing for Truth, you ready to go, buddy?
Yes, yes. Can you see my screen here?
I cannot see it yet. All right, it looks like it's coming up now. Yep, we got you.
Okay, perfect. Just 1 second. I'm going to get my timer going. Before I start, I do want to thank, no problem. I want to thank David and everybody here on Modern Day Debate for giving me the opportunity to discuss the topic of ancestry tonight with David Neff. So I'm really looking forward to this, and I believe this is going to be a very profitable and informative discussion. I mean, I've watched David debate Ken Hovind, and I know he's got some knowledge on this subject, so I think this is going to be a lot of fun. Okay, so I'm going to set my timer here for 12 minutes, and if you can see my screen, we'll get this going. Okay, let's get right into it then. What directly records a species ancestry? Well, it's genetics. It's in our DNA where the question regarding ancestry is answered. Sperm and egg don't pass on a fossil or a bone. They don't pass on geography or a rock. They pass on genetics and traits. In order to answer some of the important questions on ancestry or find out the history of humanity and discover the origin of species, this is where we must look. I know David spent some time on rocks, radiometric dating, for example, but it's genetics, genes and traits that are inherited sperm and egg. Time is not the hero of the plot for the evolutionists. So I know David spent some time trying to prove deep time, light, time travel problem, for example. Well, God may have created stars and galaxies while Earth was deep inside a gravitational well, which actually causes Earth clocks to slow down or even stop. After God stretched out the heavens, Earth came out of that well and time starts ticking. But since stars and galaxies did not experience time dilation, the universe could be around billions of years old while the Earth is only 1 day. This is gravitational time dilation and perfectly explains the problem. But like I said, time is not the hero of the plot for the evolutionists since genetic change is down. Let's look at dogs as a basic example as to why fossils being indirect evidence can't give us an answer to this question as genetics can. Genetics is so important in determining what is related and what is not. Why? Well, dogs of all types make it clear that morphology, anatomy, and bones in the dirt can oftentimes fail us because there is often more diversity within a species than between a species. This makes it difficult to classify animals by their physical traits alone. Therefore, the best way to determine ancestry is by looking at the genetics and that which is passed on sperm and egg. What David should be asking himself is this: what would he honestly expect to find if Adam and Eve were true? I think it should be obvious to anybody that we should be expecting evidence for one female ancestor of all people on the planet, as well as evidence for one male ancestor of all people on the planet. Genetic data confirms these expectations. The genetic structure in humans today speaks to us of a literal Adam and Eve. Everybody on this planet got their mitochondrial DNA from a single woman, who is exactly what we would expect from the biblical Eve. She is quite literally the mother of us all. In a nutshell, we have nearly identical mitochondrial DNA, and the very few mutations that differ from Eve's sequence are exactly what would be expected if Eve arose just several thousands of years ago. We have molecular clocks. This is direct evidence, not rocks, not starlight. Specifically, for example, the Y chromosome and the mitochondrial DNA that go back just 6,000 years to Adam and Eve. I can demonstrate limited ancestry right here and now. Those that hold to deep time evolution have been faced with very serious challenges regarding pedigree-based human mitochondrial DNA mutation rate studies. This has been a serious problem for evolutionists since the beginning of these types of studies. The reason is because pedigree-based studies and the empirical method rejects and disagrees with deep time evolution and universal common ancestry. The best tools to determine what is related and what is not related are molecular clocks and DNA function. We will get into DNA function a bit later. Evolutionists look to time dependency as a way to explain away the data. Evolutionists have suggested that the mitochondrial DNA clock ticks at different rates at different points in history. Evolutionists would have us believe that mutation rates have been significantly slower in the past. For this explanation to be scientific or even reasonable, the evolutionists must make testable predictions. And this is what I am going to request David answers in the discussion portion. If David disagrees with the Eve date derived from straightforward mitochondrial DNA coalescence equations, he needs to make testable predictions. When does the molecular clock speed up and slow down, for example? David is not the first to be asked this question. I've asked numerous proponents of evolution to make predictions. I asked this question to Gutsick Gibbon in our last debate, since time dependency was her rescue device. With no answer and no predictions, her answer was non-science. Can David here predict when the mutation rate accelerates and when it does not? Or is time dependency a rescue device that evolutionists are forced to invoke in order to explain away the observable data? The evolutionists love to accuse creationists of resorting to an answer of God did it. Well, it appears it is the evolutionists that are guilty of answering the empirical evidence with time dependency did it, or natural selection did it. Science tells us that all men have similar Y chromosomes, which is passed down from their fathers. And all of male humanity traces back to a single man. This single male ancestor of humanity has all the qualities expected if the Bible were true. A new research paper here confirms that we only observe approximately 4,500 years worth of mutation accumulation in the paternal ancestry that is contained in the record of the human Y chromosome. Subsequent papers also confirm testable predictions on the history of civilization found in the Y chromosome. How does David deal with this? Especially if he wants to look at rocks. Let's look at the direct evidence that can answer this question of universal ancestry or limited ancestry. It's creationists that are making the testable predictions on DNA function, mutation rates, speciation rates, and more. Evolution is dead. The entire junk DNA paradigm has been overturned. Orphan genes show limited ancestry. How does David here explain this incredible class of taxonomically restricted and essential genes? The chromosome 2 fusion has been overturned. The alleged site where the fusion supposedly took place actually represents a highly organized functional gene. The area is far too generate, and there is lack of evidence for the so-called cryptic centromere. Chimps have very distinctive and exceptionally large satellite sequences at the ends of their chromosomes. Where are these large ape-specific satellite sequences in the reputed fusion site? How does David address these problems? ERVs, he talked a lot about here. ERVs, ALUs, and other classes of retrotransposons. Just look at these papers here, retroviral promoters in the human genome. Well, even pseudogenes are consistent with this model of created heterozygosity. The evidence is clear. These are functional DNA elements important to our genome. I'll briefly touch on the created genetic diversity hypothesis in order that we are not talking past each other in the discussion. Where does genetic diversity come from? The major difference between my view and David's view is that I explain the vast majority of nuclear DNA differences as pre-existing or created diversity. Evolutionists assume mutations as the source for all DNA variety. This one genetic difference has massive implications for the timing as to the origin of species. If you're trying to explain the origin of species just by mutations, then the evolutionists would be right, and you would need millions of years for all these differences to accumulate. If the differences are there from the start, the simple operation of recombination and gene conversion can produce visible variety in a single generation. Migration, isolation, shifts from heterozygosity to homozygosity, and inbreeding will all, of course, play their part in producing new species. Classic textbook examples of universal ancestry that I've seen David here use in his opening include homology, right? That shared structures seen in the biological world, shared four-limb structure, for example, but we know human engineers design in homologous patterns. Across the globe, we see shared designs and even shared blueprints. What about the so-called existence of transitional forms that David talked about here? Archaeopteryx, for example. Well, think of a military vehicle that blends the features of both a land vehicle and a vehicle built for the ocean. For example, an amphibious assault vehicle, even a crossover SUV, for example. These would be the perfect examples of transitional forms, according to David here, when in fact we know this is not the case. This amphibious assault vehicle and these crossover SUVs were built and designed this way. What about those groups within groups patterns that David points to here as evidence for descent with modification? He looked at nested hierarchies in DNA. We can even look in anatomy and physiology, but these are also predicted by creationists based on the design model. The classification of life can be compared to the classification of modes of transportation on how different companies manufacture cars based on their similarities forming hierarchies. The examples that he used, antibiotic resistance, for example, the HIV resistance example as well, they're all based on losses of information. Genetic change is down. David's going to have to answer the question of net gain versus net loss. Let's look at the differentiating evidence. We're going to need to look at this in order to determine what is true. Universal ancestry or limited ancestry. Here are some questions I have for David that can most definitely help us differentiate between the two models. We have preliminary evidence for genome-wide functionality. This is a direct prediction of the created heterozygosity model. Can David refute this? Can David present us with that will select away so many deleterious mutations that are pouring into our genetics and degenerating our information systems? How does David explain the incredible dissimilarity between chimp and human Y chromosomes? How does David explain the low genetic diversity in human beings? He looked at the out of Africa scenario, but I'd like to see how that out of Africa scenario is even remotely feasible. We can talk about that in the discussion portion. We know that the ERVs that David talked about and other classes of these retrotransposons accomplish many crucial functions in regulating gene expression, differentiation, development, and even cell stress responses. How does David fit this into his evolutionary story? If he can answer that question at the beginning of the discussion, that would be awesome. Human chromosomes, for example, are made up of relatively large linkage blocks, and analyses of these original text strings tells us that the genome is young. Why? Because the genome has only been partially scrambled. Crossovers and gene conversions should scramble all linkage blocks quite quickly in an evolutionary time frame. This is a big problem for evolutionary theory. How does David explain this data? I've got a minute and a half here, a couple more questions. How does David explain the mitochondrial DNA and the Y chromosome data that, based on the empirical method, tells us we come not from just a small founding population, but a population of just two, Adam and Eve, 6,000 years ago? These are all questions that must be answered in order for David to have any chance at making a case for universal common ancestry. Why? Because these are just some of the lines of evidence that can differentiate between the two models, universal ancestry and limited ancestry. I've got just under a minute here. He also looked at dating methods, for example, but those dating methods, even including isochron dating, always rely on a few unknowable and unrepeatable assumptions. Some of these assumptions being about initial conditions, constancy of rate, and even a closed system. And even isochron dating will require an assumed history. For example, you can look at rocks that were taken from the Grand Canyon using 3 different isochron methods that all greatly disagreed with each other. So if David's going to reject, for example, a global flood, then he's going to be looking at these dating methods, and he's going to assume that these are absolute ages when in fact they're relative. Obviously, if radioisotope decay was accelerated, say during the Genesis flood, then the radioisotope decay clocks could never be relied upon when they date rocks as millions and billions of years old. But like I said, I've got 10 seconds here. Like I said, rocks, geography, these are not what's inherited sperm and egg. It's genetics. And I'd love to give David a few moments here to start the discussion by answering some of these genetic related questions, because that is the direct way we're going to answer this question. Thanks so much, guys.
All right. Thanks so much for that, Standing for Truth. Thanks for both of you guys for your opening remarks. I just want to say, anybody who's thinking, I want more. Well, you can have more, because we put their links in the description. So just go down there and you can check out their channels. All right. Be tagging Modern Day Debate with your questions, and we'll get those in at the end. We're going to start 50 minutes of open discussion starting now. David, do you want to kick it off?
Yeah, sure. Can you hear me all right?
Yes, you sound good, David. Yep. Thanks for your opening, by the way, brother.
All right. Yeah, sure. Same here. And thank you, Standing, for your opening statement. So let's start with the loss of information. I think we should start there. So Standing, the first question I have is, can you first of all give me a definition for information?
I would say that which is prescriptive, for example. And if you're going to, I guess, refer to so-called beneficial mutations that are reductive, for example, even sickle cell anemia, right? That's got a benefit. It's got a significant benefit, but ultimately it's reductive because it's due to a broken cell, broken protein, broken gene. So when something's broken or we see a deletion in the genome, that generally should imply to anybody that some type of information has been lost. That's why they can sequence these genomes, and they can look at levels of heterozygosity versus homozygosity. They can look at allelic variation, for example. So you may be able to show me 1 or 2, so-called beneficial mutations that, in a narrow sense, result in a gain of fitness. For example, even Lenski's experiment. But if you don't address the key question of net gain versus net loss, then how are we going to take that fish to fisherman, right? Because you're not going to get rich by losing money, for example. So I think, in short, something like a deletion in a genome, a lot of these mutations that degrade the genetic information, that I would define as that which is prescriptive. That type of change, I don't believe, is going to take your fish to fisherman. Take your time there, David.
All right. So with the sickle cell anemia, the example that you brought up, are you aware that that mutation also gave resistance to malaria?
Exactly. That's why I'm saying fitness can be increased in a narrow sense, but the best definition of fitness is total functionality, right? If you look at Lenski's experiments, there were some benefits to be had, but overall what we see is a total reduction in genome functionality. So yeah, in a narrow sense, these organisms, these bacteria, humans, regarding sickle cell anemia, they can have a benefit because a lot of these beneficial mutations are environmentally dependent. But if we're accumulating 100 new mutations per person per generation, with most of them being deleterious, and what we know about the known functionality of the genome, that means we're degenerating even faster. Right now, I think the key question to this, and I want to ask you, David, is how much of our genome do you believe is functional, both non-coding DNA and protein coding DNA? Because if most of it is junk, then a lot of these mutations, they're absorbed by those junk areas, making them neutral. So that would be beneficial to you and universal common ancestry. But if, as the evidence suggests, most of the genome is involved in at least some type of regulatory function, then any mutation in this genome that is nested, that is multifunctional, for example, will be deleterious. So over time, you need to give me, here's my question, 2 questions. How much of the genome do you believe is functional? And question 2, what type of selection could you provide us with that can remove so many of these deleterious mutations that are pouring into our genetics. David, take your time. I know I spoke a lot there.
All right, so for the first question, I will just say I don't know. I honestly can't give you a percentage. Now, as far as the fitness, I would disagree with your definition. I would just say fitness is anything that makes a species more able to survive. So, for example, with the sickle cell anemia example, on one hand, the mutation got the sickle cell anemia, but on the other hand, it gave resistance to malaria because the resistance to malaria was, on balance, better, and the mutation got passed down throughout the generations. Does that make sense?
It does make sense, and I do agree that some so-called beneficial mutations, and a lot of them are even epigenetic as well, so that's not really increasing information content, but it's just general adaptation based on our model of pre-existing, heterozygosity, for example. But the question that I asked about, genome functionality, it is important because it's a direct prediction of our model of front-loaded genetic diversity, that the majority of these DNA differences, nuclear DNA differences, for example, mitochondrial DNA differences, they would be functional. And you pointed to endogenous retroviruses, and now we know, and I provided about 6 or 7 technical papers in my opening showing just how functional they really are in determining cell types in the embryo, in the placenta. Are you familiar with all of this new data? I mean, even the ENCODE project, for example, David, it shows that most of the human genome is functional. And not only that, David, but functional on many levels. We've literally got layer upon layer upon layer of programming within our genome. So as you said earlier, with information, I think the best way, as I said, functional specificity communicated through, language or code, that which is prescriptive. Now, if most of our genome, as is being shown in these technical papers with the ENCODE project, is functional, that means these mutations are far more deleterious than was previously thought. So yeah, you got sickle cell anemia or a few epigenetic related changes, but that's only going to improve fitness in a narrow sense. Okay, because it's environmentally dependent. If you're going to take 2 steps up that mountain, but then 10 steps backward, you're never going to climb that mountain. So, what type of if we've got all these mutations pouring into our genetics, okay, for example, natural selection, it can act upon the best beneficial mutations, and it can get rid of the most detrimental mutations. But those nearly neutral mutations, David, like those single spelling mistakes in a book the size of an encyclopedia, for example,
right?
What type of selections is going to be able to remove that significant amount of mutations from the genetics? Go ahead, take your time, David.
Well, I would say that if it's neutral, then natural selection won't necessarily delete it and remove it from the gene. One question that I want to ask you for my case is, do you accept speciation?
Oh yeah, I like, according to our model of created heterozygosity that I touched upon in our opening, for us, we're looking back to the original creation. We're looking back to the expansion of the genome, right? Because we look to a speciation event as a sorting out of genetic information, for example, shifts from heterozygosity to homozygosity. Obviously, these breakaway populations, oftentimes they will migrate enough from the original population, they can be defined as a new species. And we've made direct predictions on speciation events, for example, on birds, snakes, lizards. But the thing is that change that we see with speciation, we see it on the Galapagos Island. We've seen, I think it was a year ago or 2 years ago, fulfilled prediction by Dr. Nathaniel Jensen, new species of finch was formed based on shifts from heterozygosity to homozygosity, just as predicted in our model. I do want to touch on the neutral mutation, I guess, a counter that you gave me. The thing is, if the majority of our genome is actually junk. Like, for example, I'm sure you're aware that less than 2% of our DNA actually codes for proteins. But the rest actually turns out to be like a huge control panel, David, with millions of switches that turn protein-producing genes on or off. So that means that the more functional our genome is, those neutral mutations that are supposed to be absorbed by those junk areas, they're now nearly neutral. They're only slightly deleterious to fitness. So once again, what type of selection can you provide us that would be able to rid from our genetics these mutations that are just slowly degrading our information systems, unless you want to hold to the view of some evolutionists that say the majority of our genome is junk. Would you hold to that view? And I do also want you to answer the question about I know we're kind of bringing up a lot of points here, but you mentioned the ERVs in your opening. So I was curious if you were aware of the endogenous retroviruses and the functions that are associated with them. Take your time. Take as much time as you need, David.
Okay, 1 second. Let me pull up my notes here. All right, where are my notes?
Even before, because are you familiar with the fact that this so-called quote-unquote junk DNA, David, it can actually modify the way chromosomes, right, the packages of DNA are organized, thus changing the way the DNA functions. So, you know, this prediction of created heterozygosity based on genome functionality, the trajectory is very, very strong for genome-wide functionality. And I'm just fascinated by the endogenous retroviruses and other classes of these.
I think ERVs are fascinating, and I am aware that there are some quote-unquote function to it, but I think that it doesn't really matter in the long run if there are endogenous retroviruses or retroviruses that have to be inserted into the cell that gets passed down. I still think that's solid evidence of that the the ERV got passed down through evolution and common descent.
Well, here's the thing, though. It's not just a few of these ERVs that are functional. Literally, these endogenous retroviruses, they have crucial functions in helping to regulate genes and even determine cell type. So a lot of the evolutionists, I've debated a biologist, you know, they'll claim that the functions were actually co-opted. But is there any real evidence for that, David? Like, my question that I asked you in my opening was this. We know that ERVs and other classes of these retrotransposons accomplish many crucial functions in regulating gene expression, differentiation, development, for example. How do you fit that into the evolutionary story? Because evolutionists have always assumed that these were non-functional leftover remnants of ancient viral infections. But ancient viral infections don't become suddenly important in the placenta or in acting as DNA regulatory elements. Because we would say, and you probably got this from my opening, we would say that these ERVs, the pseudogenes, for example, these are all created DNA units of function, right? So how do you fit the data, the most updated data on these DNA elements? How do you fit that into your evolutionary story? And take your time, David.
All right, sure. So can you, I think it'll be helpful to point out a few of these sources that you brought up and actually allow me to take some time to read the whole paper.
I can share a screen if you'd like.
Yeah, sure. Please do. That'll be perfect.
As you're answering the question, I'll share screen on the papers of the endogenous retroviruses. But what's as I'm bringing it up, what's fascinating as well, David, is that there's various classes of these retrotransposons found in mice, and when they're turned off, for example, like the embryo, the mouse stops developing. That's how important these classes of retrotransposons are in our genetics. So if you can see, I'm sharing screen. I'm not sure if you guys can see, but there's some papers here. Retroviral promoters in the human genome.
Here we go. Let's see here. Here we go. Right
here, regulatory activities of transposable elements. Right here in the abstract, it says transposable elements are a prolific source of tightly regulated, biochemically active non-coding elements, such as transcription factor binding sites and non-coding RNAs. Like, we just know that the non-coding regions of our DNA, they're incredibly important to the rest of our genome. It's like they function much like the operating system in a computer, right, David? They're directing the timing, the expression and regulation, and use of the other parts of the genome. So I mean, it's just fascinating, and it's exactly what we've always predicted, as compared to evolutionists that would say that, you know, our genome is full of ancient viral infections, leftovers of ancient viral infections, or genetic mistakes, for example. But yeah, so if you're looking at these papers here, how would you fit this? How would you fit this information into your, I guess, the evolutionary story? Like, for example, this one. I don't know if you can see Science News. Scientists
hang on one second. Hang on one second, Standing. David, are you with us right now? It looks like he got disconnected. If you could, on your side, connect him back up. All right, looks like we got him back now. All right, let's because I'm getting a lot of comments saying like we want to see David go through some of these. So maybe we'll just give him a couple minutes to try and give his side on some of these questions.
Yeah, sure.
I'll leave these papers up, and like I said before many times, David, just take your time. Yeah, I know I've thrown a lot of information and questions at you. Take as much time as you need. I'll just sit back, and you can take your time in answering these challenges and questions. Go ahead, David.
All right, sure. So the first thing that I'm just going to do is just read the paper.
Yeah, if you want to read the whole papers, I can send them to you afterwards, just to avoid dead air. But I mean, you can see them all there.
I just like having a whole time to actually just read the whole paper.
Like this one's fascinating. Intronic ALUs influence alternative splicing, even redundancy in our genome. You know, that's based on amazing design. How would evolution? Because natural selection sees that which is short term. But yet redundancy, you know, for example, these redundant elements that help slow and speed processes in the cell. How does evolution build or evolve, you know, something like a spare tire? You know what I mean? These redundant elements would require foresight. How does evolution account for those types of functions in the genome, David?
Well, first, let me just finish this up real quick. Reading. Just glancing at the paper. Right now, I'm just kind of taking a step back, looking at the paper. Regulatory activities of transposable elements from complex of benefits that you cited. I'm just going to do a quick search.
All right, while he's doing that, I just want to say to everybody that's out there, maybe you've got a really interesting question or a really good stinger that you want to get one of them with. Just tag at Modern-DayDebate or send in a super chat and get it pushed to the top of the list. David, you can start back whenever you get your place.
All right, just trying to find my place real quick. Just give me a minute.
Oh, it looks like the one I got is the redundancy of the genetic code that enables translational pausing. Yeah, I mean, there's so many papers coming out left and right regarding function in our DNA. It's almost hard to stay updated on it, but that's what's so fascinating about the creation model is so many of our predictions are coming true more and more every single day. You know, like, are you looking to just read the whole papers, or, you know, like you can see the...
Yeah, I personally like to just sit down and read the whole paper. Just so I can get a better understanding. That's what I like to do. First thing to do is just read the whole paper. This one is really long.
Right, so maybe,
why don't we exchange papers after the debate? Then?
Yeah, and so why don't we set that aside for now until you've read it, and maybe we'll move on to another salient point.
Yeah, I think what we might do is just let me have a chance to read the whole papers that you're citing, and come back for a part 2 of the debate. Would that be okay with you?
Of course, of course. And when you read the paper, I want you to jot down, how they explain, whether it's through co-option, for example, how they explain these functions, and let me know, and ask yourself too, is this philosophy or is this based on observable evidence? For example, I debated Conspiracy Cats recently, who specializes in endogenous retroviruses, and we spent probably an hour discussing this. And I asked him, I said, do you have any technical paper, any real empirical data that can show us a non-functional endogenous retrovirus going from non-functional to something extremely functional in the genome? I mean, I want you to consider the fact that these classes of retrotransposons, as I talked about, David, that are found in the mouse embryo, that if you deactivate it, the mouse embryo will develop and then stop. Well, why? Because it depends on the function of these retrotransposons, which evolutionists have always assumed was junk. Now, the patterns, the nested hierarchical patterns, that's also predicted based on the design model. Of course, we're going to share more in physiology, anatomy, and morphology with a chimp than we will with an old world monkey, or than we will with a fish, for example, right? Those nested patterns are predicted on both sides. But the one key factor that can differentiate between the two models is DNA function. And DNA function is on the side of the creationist. If you wanted to move to a new topic, we can, Dave, because I'd love to hear your explanation for the molecular clocks that I talked about with mitochondrial DNA and Y chromosome that point us right back to Adam and Eve. So take your time, David. Take as much time as you need.
Okay, sure. Let me get back. What is the paper that you're citing for that?
For the
molecular
mitochondrial Eve?
Yeah.
Yeah, I can. You want me to share screen on those papers?
Yeah, share a screen with that paper, please.
Okay. So there's multiple papers. So I'm glad that you brought it up. So we got multiple papers. And let me know if you guys can see my screen as well. Okay, so we look to... Right, so for example here, these are all pedigree-based studies, David. And here, you can see this is one of the more popular ones, the Parsons paper. Using our empirical rate to calibrate the mtDNA molecular clock would result in an age of the mtDNA of only 6,500 years. And what's amazing, David, is that there's agreement in two mtDNA mutation rate sets that exist. So there's sets that look at the D loop, that's a coding region, and that's germline, David. So that's incredibly important. And the second set looks at the entire mitochondrial genome. And when you look at both sets, they both corroborate a most recent common ancestor of just 6,500 years. This is based on the empirical method. So how would you explain that? And secondly, how would you explain that more importantly in the deep time evolution model? Take your time.
All right,
there's some more papers here too.
Again, I'm going to need to read the entire paper. Which I'd like to do is just read the whole paper and get a better idea of what the paper is actually arguing. What journal is that from?
This one's from the Journal of Science. This one over here, I believe, there's another one here, a high observed substitution rate in the human mtDNA control region. That's the D loop. I'll send you all these papers. I've got a ton of different papers, but if it's genes and genetics, that's inherited sperm and egg. And this is our direct answer to the question of ancestry, David. If you're going to ask yourself, what would you expect to find? And yet we see one female mitochondrial DNA ancestor and one male Y chromosome ancestor, consistent with the biblical-based model. How come that is not convincing to you, especially because this is all based on the empirical method, that which is observable? Go ahead, David. Take your time.
Okay. Let me, again, read the paper.
But let's just hypothetically say that you're going to read it. You're going to see that these pedigree-based studies confirm a mitochondrial Eve of 6,500 years and a Y chromosome Adam of 4,500 years. What would you then conclude? Like, would that be enough evidence for you to say, okay, limited ancestry? Are you familiar with the low genetic diversity found in humans? I mean, we're all 99.9% similar, right? Our Y chromosome is incredibly similar, 99.9% similar. And yet the chimpanzee, which you'll say is our most recent common ancestor, is less than 70% in the Y chromosome, similar to that of the human Y chromosome. And yet the Y chromosome is immune for the most part to recombination. How would you explain that significant dissimilarity in Y chromosome between our so-called quote unquote most recent common ancestor, David?
Again, let me actually sit down and read the paper and go back to your screen, if you will, please.
What, you mean you want to read the paper right here?
Trying to at least just glance at it.
Well, I think as Converse said, we could always just exchange papers after, just to avoid.
Yeah, just because
topic.
just because people will start to snooze if somebody's just sitting here reading. Maybe there's something that you're both familiar with that you disagree on. Actually, David, do you have any questions for SFT? Because some people in the audience were saying like, hey, most of the questions have came from standing side. Do you have any questions, or is there anything that he said that you want to elaborate on?
All right. So why don't we go over with the order of creation that I brought up with the failures of creationism. Since we have seen new stars form and even new solar systems that are in the plant process of forming, how do you deal with the observation that it does not fit well with the Genesis order of creation?
Let me just ask you, so we're looking at ancestry, the question of ancestry, and you want to point to like solar systems. Like, for example, I gave you an answer in my opening regarding gravitational time dilation, but I also pointed out the fact that time, you can have billions of years, even though I believe the evidence suggests otherwise. That's not going to save evolution from, especially something like we were discussing earlier, genetic entropy, because, and that's okay. You didn't have an answer for, how this problem of genetic degeneration can be solved. But if genetic change is down, if molecular clocks point to recent ancestors of just 6,000 years and 4,500 years, but then you want to look at something indirect, like let's say rocks, bones found in the dirt, or distant starlight, or just solar system formation, I mean, how is that going to help? That might help you with the age of the Earth, but how is that going to help you prove to me and the audience that, pine trees and whales are related? Like, I'll answer that question. I mean, that would be my answer, is that, these things are indirect, but I'd like to see the best evidence from you, because I've given you some solid evidence for a young genome and limited ancestry, but what would be your best evidence for universal common ancestry, right? The claim that fish, humans, and apes are all related. Because is solar system formation, is that your best evidence for universal common ancestry? Or just try and help me understand that, David.
So the solar system thing that I was showing you is just proof that the Bible got the facts wrong, which calls into question the whole account. As far as the strongest evidence for evolution, and I would say the strongest evidence is that we observed it happening, which you seem to agree with. You agree with microevolution, and you even agree with speciation. Let me ask you the question: why isn't speciation enough of a reason to accept the theory of evolution?
What type of speciation event are you referring to specifically? Like, what was the genetic change in these specific speciation events? Because I showed you a recent speciation event in the Galapagos Islands with the finches, and we've predicted, based on our model of created heterozygosity, right? The fact that God front-loaded Adam and Eve with pre-existing functional DNA differences, and of course this applies universally to species. We'd be looking back in time at the expansion of genetic information, while the evolutionist looks back in time at the contraction of genetic information. Because if you're going to start out as a single-celled ancestor to a multi-celled ancestor to a fish to an amphibian to a reptile to a mammal to a bird to a monkey to a man, that's going to require the expansion of genetic information. But the speciation events we see, they generally include reduction in information, shifts from heterozygosity to homozygosity. So the reason why that's not evidence for fish to fisherman evolution or a single-celled ancestor to a whale type evolution is because the genetic change is opposite of that, which is required for that type of large-scale evolution.
I guess the speciation I would be referring to, I guess we can start with like the SIV, HIV, speciation.
Would that be like an example of a beneficial mutation? That, like, is that actually, because was this an example that you said was found in humans, the HIV resistance example?
Yeah, well, the HIV, SIV, how they diverged into new kinds of viruses, completely.
And this was the HIV. What was the details on the change in the viruses? Like, was it due to reduction in information, broken promoters, broken systems, broken ribosomes, like in the antibiotic resistance? Like,
yeah.
I'd have to look at the exact. Is that what it is?
Let me pull up my screen. I think that'll help you.
Sure.
Let's see if I can. Can you see my screen?
Let's see.
All right, there's the quote from the book that I cited. The virus had to mutate and how it overcame those mutations. Take your time.
Yeah, no, I would just say that, you know, what I'm going to predict that these changes are consistent with loss of function, loss of regulation type mutations, or just basic epigenetic related changes that, because it seems like the evolutionist doesn't believe, like, we do believe in change over time, and we do believe in microevolutionary variations where you could be getting the changes in the frequencies of these alleles and the expression of these different traits and things like that. But it's the type of traits, it's the type of changes, it's the new innovations, the new structures, the body plans, the novel information. And if the best example that you would have is these changes in the HIV virus as demonstration for that type of large-scale fish-to-fisherman type evolution, I mean, the majority proves the rule. I mean, if we're accumulating 100 mutations per person per generation, the majority of them are deleterious, degenerating our information systems. I mean, is that proof enough for you that you have evolved over billions of years from a single-celled ancestor? You know, like, if you get what I'm asking.
Okay, I don't think so. Since you seem to agree with speciation and stuff like that, the question that I have is, where exactly do you draw the boundary lines where one species or whatever, what is the limits, I guess is what I'm asking, where one quote-unquote kind of animal changing into another quote-unquote kind or new species, where do you see the actual boundary being? Where, like, there is somehow some type of evolutionary path where it can't change beyond this?
That's a really good question. So I think that that's going to get into our model of created heterozygosity as well as nested hierarchical patterns. But we've got many different ways that we can look for a boundary. In Ancestry, for example, DNA function, as we talked about earlier in great deal, we can save that for another day so you can look at those papers. We also look at orphan genes, for example, that I talked about in the opening, and the problem for the evolutionary model of animal origins in regards to orphan genes is that these novel DNA sequences, David, and the unique traits that they're often associated with appear suddenly and fully functional without any trace of evolutionary ancestry. So therefore, the orphan genes that are specific to, say, humans, that are not found in some of the great apes, would draw a line or a boundary in that hierarchy. So I think orphan genes would be a great way to draw a line. Like, how would you explain orphan genes, for example, those taxonomically restricted and essential genes in your model? Because it fits nicely in our model of biblical kinds. Take your time, David. Take your time.
All right, sure. So I'm just pulling up a paper right now on the evolutionary origins of orphan genes. This is from Nature. Quote, current model of gene evolution have concentrated on mechanisms that are mediated by duplication and transposable elements. But these models have not yet fully evaluated the possibility of de novo evolution. Orphan genes with no homology to genes in other evolutionary lineages occur in all genomes and are candidates for de novo. Let's see here.
So so in other words, would you say that the explanation for orphan genes is de novo gene synthesis?
Possibly.
Because it sounds like that. See, and here's my rebuttal to that, because I've read all these papers as well. It's just like the endogenous retroviruses or the ALUs, for example. They'll say that those functions were co-opted. With the orphan genes, they will look to de novo gene synthesis. And I do believe that that's a circular-based argument. I'll tell you why, David. It's because evolutionists say de novo gene synthesis must be true because orphan genes exist. And orphan genes exist because of de novo gene synthesis. So do you see the circularity in that? I would call it a rescue device, because they're just inferring, oh, look at these orphan genes. They must have been adopted through gene duplication, or somehow a non-coding region of the genome popped up and became protein coding and functional. But they're not actually observing this in real time. So do you see the circularity in that argument there, David?
No. Let's see here. I'm just reading papers here now. But yeah.
Well, is there any answers other than de novo gene synthesis in these papers? Like, do they actually observe it real time? These non-coding areas of our genome popping up as a protein coding gene, incredibly important and essential in these species and lineages, or is it just inferred, as I said?
Yeah, I'm not sure. Here we go. Here's a paper. Trying to think here. But yeah, I think we should definitely exchange papers and have a part 2 of this discussion.
Well, let me, okay, yeah, and that's fine too. Let's go to something even just a little less technical. Let's say kinds, okay? So,
yeah,
you brought up kind.
What's a kind?
Yeah, there you go. We'll make it fun for the audience now. So I would say my definition of kind would be, but I do want to point out to the audience that I do believe that molecular clocks, DNA function, taxonomically restricted functional endogenous retroviruses, taxonomically restricted and essential orphan genes, these types of lines of evidence can draw a boundary. And I think I've proven that today. I just want to point that out. And I know you disagree with that and you got to look at the papers, but those are, like, for example, DNA function and molecular clocks. Those are the two best ways that we can determine what's related and what's not. And I think I've proven that, but yeah, we'll wait for you to read those papers. But when it comes to just a basic definition of kinds, my definition would be groups of living organisms would belong to the same, say, created kind if they have descended from the same ancestral gene pool. So I would say we can infer, and I'm sure you would agree with this, with really good certainty, David, that dogs, wolves, let's say coyotes, and maybe foxes all go back to an original ancestral gene pool. But I don't believe we can scientifically infer that dogs, wolves, and pine trees go back to an original ancestral gene pool. And once again, I believe we can demonstrate that with molecular clocks, orphan genes, DNA function.
Okay, so you're saying that maybe God or whatever created an archetype of dog that gave birth, that eventually gave rise to the various types of dogs and foxes and all that?
Actually, that's a really good question. So we would look to the idea of pre-existing genetic diversity, David. So this means that God created Adam and Eve with differences within themselves. And this hypothesis, this created heterozygosity hypothesis, would then apply universally among species. So yeah, let's use dogs as a basic example. There, David. Noah brings aboard 2 dogs, and now we have everything from wolves to coyotes to jackals to foxes, and in between, and of course, ultimately the domestic dog. Or we can look at let's say cats. So for example, the cat ancestor aboard the Ark was front loaded, as I talked about, with a whole bunch of these functional DNA differences at creation. These front loaded functional DNA differences has led to the origin of species, right? So Noah brings aboard 2 cats, and now we have everything from tigers to house cats to jaguars and in between. And we can even see that in the species we see today. What is there? Between 30 and 40 different types of cat species, David, is that roughly what we have?
I guess so. I'll have to look it up. But so the question is, if that's the case, then why couldn't God have created like a archetype of the primate and have all the descendants of primates descend from that? Or and you get where I'm going from?
Are you saying that? Are you including humans in the primate category?
Yes, I am, and we can debate that.
And that's a hypothesis that we've that we've tested. There, before I answer that question, there is a paper that I want to send you as well. If you've never heard of it, there's no point in going into it any further. I'll answer your question on the primates. But there is a new paper that demonstrates that 90% of all life has the same level of genetic diversity, David, meaning almost all life on Earth is the same age. And they use something called DNA barcoding. They can go right into the mitochondrial DNA, and they can look at what's called the CO1 gene. It's highly, highly conserved. And the diversity in that gene demonstrates that over 90% of all life has the same level of genetic diversity. So it's pretty fascinating, actually. But yeah, so we've tested that model regarding the primates. Did God create one created set of primates, and they've all diversified into humans, bonobos, chimps, gorillas, orangutans, et cetera, et cetera. But the molecular clock tests failed when we included humans in with the primates. The orphan genes, the functional endogenous retroviruses, for example, the DNA barcoding was all inconsistent with including humans in with the other apes. So therefore, scientifically, we can't actually include them as true primates. Go ahead, David.
Okay, so with the whole ARK story, how many species, how many kinds, or what do you say were on the ARK total? Let me give you some time to answer that.
How many actual species in general?
Like how many kinds of animals were on the ARK? Let me give you some time to answer that.
Sure. Yeah. Let's say as a working hypothesis, God between 6,000 and 8,000 kinds of animals, and when we actually pick out certain kinds, let's say he brought aboard, let's say 80 different bird kinds, for example. Well, we can look at the number of bird species that we have today, and we see that there is approximately, I think it's about 11,000 bird species today. So that's really only between like 2 and 3 new bird species per year to account for that. And like I said, we just seen one with the new species of finch. Now, here's my question.
Okay.
Certainly,
I'm going to follow up before you ask it. Before you ask your question.
Of course.
So, how do we get the 10 million plus species that we have today from 8,000 kinds of animals that were on the ARK in just 4,500 years? Using the molecular clock, that doesn't seem like enough time to give us several the millions of species that we have today. Let me give you some time to answer that.
Yeah, no, I think that's a good question. I think I did answer that when it comes to our model of pre-existing genetic heterozygosity, for example, because you can even look, I mean, genetically speaking, this all goes back to Gregor Mendel, for example. He actually lived at the same time of Darwin himself, and just basic genetic principles. Think of capital and lowercase letters, okay, David? So we got big A, little a, big B, little b. These letters constitute different features and traits, for example. For me to break it down, if you have a capital A, let's say for dark skin, and a little a for light skin. Now, if you have a couple such as Adam and Eve, what were Adam and Eve according to their skin tone? Well, if they were homozygous, for example, let's say they were capital A, capital B, then both of them would have dark skin, and all they can produce now is dark skin. And the same thing would be true if they were all lowercase letters, which would mean they can only produce light-skinned people. But if Adam and Eve are a mix of capital and lowercase letters, capital A, lowercase a, capital B, lowercase b, and we're, say, a middle brown skin tone, they have the potential to produce every shade of skin that exists on the planet. So the point is, Adam and Eve, and this would apply universally to all species, would have had the potential within their DNA to produce, in terms of Adam and Eve, every shade of skin that exists on the planet are known to man. And regarding species, whether it's the cat species, the dog species, the horse species, that pre-existing genetic heterozygosity based on these pre-existing DNA variants, just through recombination, gene conversion, for example, can explain all the species we see today. I mean, as I pointed out, we've only got about 11,000 to 12,000 bird species, okay? But yet, if evolution is true and birds evolved from theropod dinosaurs 65 million years ago, and they've been evolving for millions and millions of years, why do we only have something like 10 to 12,000 bird species? I mean, how do you account for that? Just a bunch of extinction events, or yeah, go ahead, David.
But yeah, obviously we do have about 10,000 bird species. Not quite sure, don't quite understand the question. Obviously, looks like here number of bird species soars to 18,000. But of course, as we learn more and discover more each day, we simply don't know how many bird species there actually are or were. Obviously, things go extinct all the time, and there were any extinctions events in the past that could explain that. With your clock, so to speak, from 4,500 years ago from the flood, how many new species have to evolve each day in order to get the millions of species that we have now? I'll give you some time to get to that.
Really good question. I did cover the bird ones, right? It'd be about 2 to 3 per year. That's a testable prediction made by Dr. Nathaniel Jensen. And after that prediction was made, amazingly enough, a new bird species on the Galapagos Islands was observed in real time. And that's, we've been studying the Galapagos Islands. So 2 to 3 per year for 4,500 years is not, that's a pretty easy task. And what I find funny too is—
I'm not going to talk about bird species. I talk about all the millions of species of
Of course. Well, I'm just saying we can't look at it in just like, hey, this is how many species we have altogether of every single kind of animal. We got to break it down. Let's look at birds, lizards, and snakes, for example. There's only like a few thousand really of each. So that's like one, sometimes less than one per year. Let's look. I want to cover this because this is really important, and I'm still answering your question, but let's look at the horse, donkey, and zebra family, for example. So we've talked about lizards, reptiles, birds, cats, dogs, bears. Let's look at the equids, okay? So there exists, David, 3 species of zebras today. What is it? I believe it's 1 wild horse species, 3 wild asses, 7 species total, okay? This is what I find fascinating, David. There exists over 850 breeds of horses and donkeys in the world. Okay, so let's ask ourselves this question. David, ask yourself this question. Where did all the breeds today come from? Okay, well, this is an easy and obvious answer, I think, since we humans, are the ones who are responsible for producing these breeds. So
right, humans created them through interbreeding.
So therefore, all these breeds obviously came from a common ancestor. 850 breeds came from a common ancestor at some point during human history. Now, here's my question. How could we get 7 species of equids from a pair of equids on board the Ark thousands of years ago? Well, I'm just going to ask the evolutionists today about how long it took to get the 7 living equid species, because the literature will tell you, David, and you might already know this, will tell you that about 4 million years it took to get just 7 species of these equids. But yet, how long did it take for over 700 breeds of horses to arise? Well, 7 species in the wild and over 700 breeds, that's over 100-fold difference, David. 4 million years for the wild, but apparently only thousands of years for the 700 plus species. So this is just one example.
Yeah. Well, of course, breeds and species are very different. Speciation takes a bit longer and requires sexual reproductive isolation and other factors that would go into creating new species.
Well, I'm just saying that this is just one example as to the plausibility of all these species in just thousands of years. Just have a look at what has been done on the farm. And remember, they're just taking the pre-existing genetic diversity and they're just reshuffling it, for example, recombining it, and they're coming up with these new variations of on the farm, for example. But that's how we say, and just so we're not talking past each other, David, how would you, because I explained in my opening, and I know we both touched on a lot of points, I explained in my opening where we believe the origin of genetic diversity comes from, especially with nuclear DNA, just so we're not talking past each other. Do you remember what's the difference between my model and your model in terms of the origin of genetic diversity? Take your time.
Okay, so yeah, easily. The obviously different is obviously number one is the time. The whole time factor being off by a pretty large factor, 6,000 years versus 4 billion years or so. And then of course yours would require an intelligent designer, aka God, whereas mine would not. Those are the 2 biggest differences in our model. One thing that I wanted to address before we get to the Q&A.
Real quick, and I want you to address that, but I just want to expand on what you said. So Are you saying
Yeah,
that?
guys, we only have a couple more minutes, and then I'm gonna give you your closing statement. So
Okay, real quick. So just for the audience sake too. So are you saying that you explain the vast majority of the DNA differences that we see within species, across species, as a result of mutation over time?
That would be fair. Mutation and other factors, mutations, natural
Well, I mean,
selection.
mutations would be those DNA differences would be the result of mutations, but the actual variety and the change would be like recombination and gene conversion of those DNA differences that were ultimately the result of mutation. Like what else other than mutation, according to your model, can produce these DNA differences?
Oh, natural selection.
Well, yeah, but natural selection is acting on those pre-existing DNA difference. Because all I'm saying is the big difference between my view and your view is that I explain the vast majority of nuclear DNA differences, not by mutation, which is how you explain them, David, but by pre-existing or created diversity. And that one genetic difference has massive implications for the timing of the origin of species, the DNA function of the species, the molecular clocks in these species. And I'm saying all of those factors combined points to a limited ancestry and rejects and refutes a universal common ancestry. So go ahead. If we just have a minute left, you can have the last word there, David.
All right, sure. So one last word that I wanted to argue, that I wanted to go before we go into Q&A is your example of cars and various design. This is, I believe, a perfect example of the fallacy of false equivalency. It's a fallacy, it's a false equivalency because cars do not have the ability to reproduce and they do not have the ability to mutate and all that like living organisms do. So this is that's what I see as a fallacy of the false equivalency.
So if you're talking about the nested hierarchical patterns that I point to, and I point to the modes of transportation that humans have designed, well, it just so happens that humans design in these hierarchical patterns, and saying that, cars don't reproduce is pretty much just a misrepresentation of our model. Because we're saying that if we were made in God's image, David, then we can get a sense for how God would have created life by looking at the way we create things. And just accidentally, we build in these hierarchical patterns. For example, all sedans share a tremendous amount of features with other sedans. And yet you can bring in SUVs and vans, and obviously all sedans are more similar to each other, but they do have similarities with SUVs and vans, but the dissimilarities separate them. But then you can bring in airplanes and boats, and you can look at the materials used, and you can build a groups within groups
Right.
hierarchical pattern.
So of course, it'll remain a false equivalence fallacy as long as cars can't reproduce. How much longer do we have?
Let's actually go into, you guys wanted a couple minutes for closings. If you want to give a brief closing, and we'll give both of you guys a chance, and then we'll jump straight into Q&A.
Of course, yeah, David, if you want to start with your closing, and then I'll end it.
All right, yeah, sure. So we are definitely going to be doing a part 2 of this debate. And I hope that everyone joins us. I just wanted to give it some time to actually read the papers. I really enjoyed our discussion. I think it was very cordial and very friendly. And I hope you enjoyed the conversation as well. So yeah, couple of things, couple of upcoming debates that we're working on doing. I am looking to have another debate with Ken Hovind on evolution and creation. I'm also looking forward to debating Praise I Am That I Am on the topic, Did Jesus Rise from the Dead? So those are some things that I'm looking forward to and that I hope that you guys can join me with.
All right. Thanks so much for that, David. SFT.
Awesome. Yeah, I think it just comes down to that which is testable, that which can be falsified. And, we're making the predictions on DNA function, molecular clocks, for example, and those types of evidence, those lines of evidence that are agnostic to the debate, like the nested hierarchical patterns or the homology, or just a few mosaics, for example. These are not going to help us answer this question of ancestry. It's those lines of evidence that can differentiate between the model, and those lines of evidence are what David's going to go look into more, and we can discuss in more detail detail in a second debate, because I believe those are the lines of evidence. Orphan genes, DNA function, for example, is going to determine what's true. Limited ancestry or universal common ancestry, because the phylogenetic systematics, the nested hierarchies, for example, universal common ancestry, it is mostly based on the assumption that these DNA differences, the origin of genetic diversity, is mutation over time, and that the majority of the genome would be based on evolutionary leftovers, genomic fossils, and ultimately just junk DNA, and even parasites, for example, these endogenous retroviruses. But these are all proving to be functional DNA elements, not mistakes, not the ancient remnants of ancient viral infections. And the molecular clocks prove a young genome, and that is a direct way to demonstrate the youth of the genome. Like I said, the rocks, the dating methods, they're all based on assumptions. It also assumes that there wasn't accelerated nuclear DNA decay during the time of the flood. And I said that if radioisotope decay was accelerated during the Genesis flood, then those radioisotope decay clocks could never be relied upon when they date rocks of millions and billions of years old. And that's why when we take rocks of known age and measure them, they come back wrong. But yeah, you want us to believe rocks of unknown age? No, we need to look at that which is direct. So yeah, I really enjoyed the discussion, David. I think we touched on a number of really good points. It flew by. It was engaging. So thanks so much for doing this, David. Thanks so much for moderating Converse, and thanks so much for being the behind the scenes guy. Praise. That's it for me.
All right, thanks so much for that, Stanley. All right, so we'll jump straight into the Q&A section here. We've got a lot of questions. We'll start with our first super chat from Steven Steen. Thank you for your $2. Says, woo! SFT is an unstoppable fact machine. Hashtag bow to his brain.
That's him to say that.
Yeah, I was going to say, you're going to have to pay him back, your stepbrother. So, all right. We have 199. Looks like we don't have a. Oh, that must be from Steven Steen as well. Steven Steen, another $2 super chat, says, my 400th YEC debate, Young Earth Creation debate, still don't know what an ERV is.
Is that a question for me? Actually, can you repeat that real quick?
Yeah, he says, my 400th YEC debate, still don't know what an ERV is.
Yeah, you know, I've touched on ERVs many times. I'd recommend looking at my debate with Conspiracy Cats as well. I'm fascinated by the topic of these ERVs that the evolutionists will say are the result of, ancient viral infections. But I've said this many times. There's a question that we should all be asking ourselves, and that question is, what are these ERVs? What are these retrotransposons? Are they really the leftover remnants of viral infections in our DNA? Or, as I pointed out to David, are they created units of DNA function? And, this is a testable prediction that creationists and intelligent design advocates are making and have been making. And at this point in time, the trajectory of experimental results actually points to increasing in surprising levels of function. And I showed probably about 6 to 8 papers providing evidence to David of the incredible functions found in the in the genome regarding the ERVs. So yeah, anybody wants to debate that topic, I'd be more than happy. I've debated biologists on this topic. So yeah, give me an email and we'll set it up.
All right, thanks so much for that. Standing, we've got quite a bit of questions tonight, and they're mostly for you. So we'll try. What we'll try and do is so we'll try and do like as quick as possible. That way we can get in as many as possible. Cool. Cividor Energy, $10 super chat. Thanks so much for that. Sarah asked, STF. Okay, you still don't understand mitochondrial Eve, which points to not the first female of a species, but merely the most recent female, and it wasn't 6,000 years ago. What do you have to say about that?
I love it. After all these debates, these are the arguments that I even directly refuted in my opening. And these are arguments, and I've even showed papers that based on pedigree-based studies, and even studies in the D-loop region, whole mitochondrial DNA studies, multi-generational studies, for example, all point to a mitochondrial DNA ancestor of just 6,500 years. But when evolutionists do these analyses, now they have to reject the empirical observable method, for example. And mind you, they can't make any testable predictions. My debate with Gutsick Gibbon proved that. I asked David to make testable predictions as well. We've made testable predictions. Dr. Nathaniel Jensen, based on the known mutation rate, has made future predictions on African people groups, the Khoisan peoples. He said, listen, he pointed to them, their measured mutation rates are not known. And he said, I predict that their DNA is going to change this many times per this many generations. So it's the creationists that are doing the science and not the evolutionists. So anybody who wants to debate me on that topic as well, molecular clocks, set it up. I'd love to.
All right. Thanks so much for that. Yep. All right. Thanks so much for that. Robert Sommers, $5 super chat. Why is SFT using cars as examples? Why not use biological examples that disprove or shows design?
Yeah, good question. So I do use real-time observable evidence regarding DNA function, regarding obviously molecular clocks. I'm sure everybody listening can see that, other than I guess the questioner. But I'm just pointing out the fact that it doesn't take much. It's just common sense that based on both models, we're going to expect a lot more similarity between a human and a chimp in anatomy, morphology, physiology, genetics than between a human and a fish. This is just those groups within groups patterns that both models predict. And it just so happens to turn out that accidentally humans design in nested hierarchical patterns. Humans even design modes of transportation such as amphibious assault vehicles or crossover SUVs, which according to David and the evolutionists would be the perfect example of a transitional form. No, these are all agnostic lines of evidence that both models can explain. That's why I always point out, hey, listen, let's look at that which can differentiate the two models. Molecular clocks, DNA function, for example, DNA barcoding, and these differentiating lines of evidence are on the side of the creationists. We're the ones doing the science. Thanks for the question.
All right, thanks so much for that. We have a question from PZ Barnes says, I'm sorry, I think I missed one. 1 second. Yeah, Steven Steen, another $2 super chat. Thanks so much, Steven Steen, for your support. Says, well, shoot, I'm convinced. Call it for SFT. RIP Evo.
Right. Steven Steen with all those super chats, he's putting our kids through college. So
exactly.
Thanks, Steven.
All right. Next we have another question from Stupid Whore Energy. Thanks so much for your other $10 super chat. It says, please cite the paper that overturned chromosome 2 despite it being mentioned in many recent papers. If you cite a creationist paper, I'm going to slap you.
Super Whore Energy is getting violent now. Yeah, I've pointed out a number of reasons why the chromosome 2 fusion has actually been overturned regarding function. Why is the area so degenerate? For example, the lack of distinct chimp-related satellite DNA, lack of evidence for cryptic centromere. I mean, there's more and more and more. But I do have papers, for example, the evolutionists will say, okay, the area is so degenerate because of deep time evolution, for example, but we do still have some telomere-like motifs there. Well, guess what? Those telomere-like motifs are found all throughout the genome, and they're found to be functional DNA elements that are not even associated with any type of fusion. So I've got secular papers showing those lines of evidence, or showing the lines of evidence that suggest that the so-called cryptic centromere site is actually overlapped by a functional gene. These are all from secular papers. And there are papers by creationists, of course, Jeffrey Tompkins going in in detail as to why this isn't a fusion site. But for more on this, I would recommend my last debate with Erica Gutzig-Gibbon. I think we discussed all these lines of evidence for about a half an hour. So anyone who's interested, go check that out, or anyone who's interested in debating me on that topic, let's set it up.
All right,
What's the actual paper?
I'm sorry?
I mean, David, let's get real. I've shown about 20 papers here. I will include that paper as well in the I'll mail it to Super Horror Energy. What's your mailing address?
All right, thanks so much for that. We'll move on. We have a $5 super chat from P. Barnes. Thanks so much for your super chat. It says, can SFT explain the shared genes between monotremes and birds? I may have mispronounced that.
Monotremes and birds, shared genes?
Yeah.
Yeah, I would say that shared genes are simply evidence for a common design. We'd have to look at the function as well. For example, we can look, we made direct predictions based on this model of created heterozygosity on, let's say, the cytochrome C gene in the mitochondria, for example, those mitochondrial proteins that are conserved. We are predicting that depending on the kind of animal that we're looking at, those shared genes will have multiple functions. And then we look to protein moonlighting, for example, which is a new fascinating discovery that these proteins are doing multiple things. So those shared genes are, yeah, they're functional, but a lot of the times they are, like with the monotremes and the birds, they may have additional functions on top of the functions that are basal to that specific species. So these are predictions that we're making, and they're in print. So I'd be happy to show anybody those.
All right, thanks so much for that. We'll move on. We have a $5 super chat from Stupid Horror Energy again. Sarah says, ERVs aren't evidence for common descent because of their supposed lack of function.
Was that Super Horror Energy?
Yep.
Was that a question for me or David?
That question must have been for you.
So what did they say? That ERVs are not evidence for common descent?
Yeah, exactly. ERVs aren't evidence for common descent because of their supposed lack of function.
ERVs are not evidence for common descent because the evidence suggests that they are created units of DNA function. I've shown that they accomplish many crucial functions in regulating gene expression, differentiation, and development. And I've gone over about 6 or 7 papers, and the distribution of them, that nested hierarchical distribution of the ERVs, makes sense. We would expect to find more shared functional DNA elements in a human and a chimp than we would with a human and an old world monkey, or a human and a fish. So like I said many times, those patterns, those nested patterns, are predicted on both sides. It's the function of those patterns that can differentiate between the models and the functions on our side. So,
all right, thanks so much for that. The Stolen Earth did ask if you didn't mind citing the paper for him. I don't know if you want to go ahead and do that now, or if you want to just maybe include it at the end.
Is that the paper for the telomeric-like motifs in the chromosome 2 fusion, the functional elements?
The last one that you cited to David, somebody was like, hey, do you mind if I get a citation for that?
I will cite that one, and another one that I cited in my actual presentation. I had a screenshot. It had to do with the, I'll pull it up. It had to do with the title of it is The Evolution of African Great Ape Subtelomeric Heterochromatin and the Fusion of the Human Chromosome 2, and why those sequences that should be flanking the reputed fusion site are not found in the reputed fusion site. So that's a huge problem for the chromosome 2 hypothesis. So I just cited that one, and the other one, the telomeric-like motif one, I will provide as well with all the other papers.
All right, thanks so much for that. Brian Stevens has a Patreon question. He says, SFT, I didn't catch the paper that debunked chromosome 2 fusion. Can you be specific with the authors and title of the paper? Well,
I just named one regarding the lack of ape-specific satellite DNA. I've got a paper here showing that the so-called cryptic centromere, actually just problems with the alleged cryptic centromere in that its human alphoid repeat DNA sequence does not closely match chimpanzee centromeres and chromosomes. I'll provide the secular ones and the ones from Tompkins. Now they'll scoff at Tompkins because he's a creationist, but guess what? They can't refute his data. And I've studied his data in great depth, and I am willing to pretty well debate anybody on that topic. I've debated biologists on that topic. Erica, for example, and Brian Stevens, who, what's that sound a chicken makes? I doubt he'll do it, but if he wants to debate that topic, set it up, baby.
All right, thanks so much for that. We'll move on. Another $2 super chat from Sunday Warship. They say, for SFT, when did Gish first develop ability to gout? Oh, okay, so I think that's kind of how he's taking this shot at there.
David, this time you paid him to say that one.
Yeah, you get your money worth. All right.
Yeah.
We have I'm getting a lot of music background noise for somebody.
I'm not sure. That wasn't me. I'm not sure who that was.
Okay, so Shadow Dancer 3531, thanks so much for your $10 super chat. Says, David, when you did your DNA ancestry, how come ape DNA wasn't in it? Fish DNA, bird DNA, question mark? If we have messages left over from evolution, then we should see this in our current DNA. All you saw was human DNA.
That is a word salad. And to the question, I'm just going to laugh at it because obviously with the Ancestry.com DNA, we made a site and it only takes you back so far. It doesn't do a full genomic analysis, but just gives you a decent idea of where your ancestors came from. So that is just a total straw man, and it is worth a belly laugh.
All right, thanks so much for that. We'll move on. We got another $10 super chat from Stupid Whore Energy.
Whoa.
Just has all the money just laying around.
Yeah, before you read that question, I would just say it must be nice to have enough money to just do $10 super chats.
Yeah, there goes all Super Whore Energy's toilet paper money. So
I think that she's pretty up there as far as money goes. It's like, hey, look, if you got a short question, you don't have to do 10. You can do like 5. But anyway, thanks so much. We appreciate the support. All right, James has done a great thing with this channel, and so Sarah's always supported. So, Stupid Whore Energy, $10 super chat. The evolution of a channel forming protein with preference for cations, VPU, in viruses is impressive because of how many they mutate. They are macroevolution similar.
I'm sorry, you kind of froze up on me. I can't hear you.
Okay, I'll try to read this again. The evolution of a channel-forming protein with preference for cations, VPU in parentheses, in viruses is impressive because of how madly they mutate. They are macroevolution simulators.
yeah, a lot, even viruses, for example, like they will mutate and burn hot and fast fairly quickly. Like the H1N1, for example, direct prediction from Dr. John Sanford on genetic entropy. The H1N1 virus, I believe it was 1917. There is a paper on it that I can cite as well. It went from a red hot pandemic to a whimper to an extinction event in less than 90 years, and it was due to a linear accumulation of deleterious mutations. So a lot of these RNA viruses, they will mutate fast. Mitochondrial DNA in all species, for example, mutates fast. So there's no clock slow enough for deep time evolution. And anytime that they say, oh, the clock's been different in the past regarding, say, ntDNA molecular clocks, they need to make testable predictions, and they can't. So their answer is non-science and nonsense and is a rescue device. So good comment.
All right, thanks so much for that. Terry James, $5 super chat, says, ancient Egypt records records both house cats and lions. So the cat species had to evolve hundreds of years after the flood.
Yeah, I mean, like I said, so if God brought a couple cats, for example, on the ark that were at creation at least front loaded with these functional DNA differences that do lead to testable predictions on DNA function, we can make predictions on mutation rates, speciation rates, and a few hundred years, whether it's 800 years or, for example, after the flood, can account for the depictions that they have regarding, what did he say, lions, tigers, because visible distinctiveness, if those DNA differences are built in, they can, visible distinctiveness can occur rapidly just through processes like recombination and gene conversion. You don't even need mutations over time like the evolutionist needs, since ours are already built in. So yeah, actually, if you want to do a couple speed rounds there, Converse,
Yep.
I've had a few bottles of water and we've been talking a lot, so give me 1 minute.
Yeah, no problem at all. So let's see if we have a question for David in here. So we have a $5 super chat from Serious Startups that says, RJ, you literally said Snapchat, Google, Twitter, and YouTube code could write itself. You can't be taken seriously. Stop saying SFT doesn't read papers. So I don't think that was for either of the contenders, but so I thought I'd get that in there real quick. We have I'm sorry, I had a question, I think, for you, David, while he's
Okay.
in there. Early on, let's see. Nope, that was for SFT as well. Looks like he's going to get the majority of the questions tonight, so sorry about that. But
how much time do we have left?
well, we just have until we finish the questions. So are you need to be going pretty soon?
Yeah, because I have to work tomorrow morning. How many questions do we have left?
About 10.
All right, sure. So any of them for me?
Let's see. And standing for truth, just let us know when you're back, buddy.
Oh yeah, I'm back.
Okay,
ready to go.
All right, so we had a super chat question. You mentioned front loading. So just really, if we could get through these as quick as possible, because
I'll give 1 sentence answers. Yeah, you're right. I never answered all these before in previous debates. So go ahead, brother.
You mentioned front loading. John Rapp had a $2 super chat that says, "Please explain the term front loading."
So I've said it many times that we would explain the origin of genetic diversity as created genetic diversity. I gave a really lengthy explanation to David in the debate regarding alleles, allelic diversity, right? Capital A, and whether these alleles are heterozygous or homozygous. So front-loaded means that those DNA differences, those DNA variants, were created by God. They were front-loaded into Adam and Eve, which would apply universally across species and kinds, of course. And as I've stated, that hypothesis is not ad hoc because it leads to testable predictions on DNA function, mutation rates, and speciation rates, and many of them have already come true. So thanks.
All right, thanks so much for that. Logos Dio said, future question for SFT. Did T-Rexes eat watermelon before the fall?
Did T-Rex evolve, or did T-Rex eat watermelons before the fall? I think that's more of a trollish question. I don't know what the T-Rex looked like or ate in the garden.
I think the question really is whether you think he was a vegetarian before the fall.
Yeah, before the fall, yes. After the fall, I think they were all originally created to be vegetarian after the fall, and for example, mutations started accumulating, and death and extinction, and animals became carnivores, for example. But everything in the garden, everything pre-fall, I do believe was vegetarian, of course, because I believe death came as a result of the fall. So
all right, thanks so much for that. Robert Sommers, another $5 super chat, says, SFT, do you promise to hold to arguing the papers traded and not try to shift to new ones in the next debate?
Yeah, every single paper that I had in my opening are papers that I've also had and used and cited in all my previous debates. So those are the same papers I always post in the chats, and I've had nobody ever refute them. I've pointed out the philosophy aspect of these papers, how the evolutionists, the researchers will say, oh, okay, these functions must have been co-opted with no real empirical data. But I'll discuss any number one of these papers with anybody.
All right, thanks so much for that. P. Barnes says, $5 super chat, thanks so much, says, standing for truth, just to clarify, a platypus and a bird are evidence of common design. Take your time.
For example, a platypus, I think, a platypus is like a mosaic. It's like an Archaeopteryx or a Tiktaalik, for example. And of course, evidence for design. I mean, what did a platypus evolve from, for example? And I know ultimately, they'll say that a platypus evolved from a single-celled ancestor billions and billions of years ago, which there's no scientific evidence for. But the platypus itself, it defies deep time evolution and deep time evolutionary change. So yeah, evidence for design, sure.
All right, thanks so much for that. David, we had a quick question for you. Somebody just wants to know, what is that blue thing in the top of your picture sitting on top of that PA or whatever?
Repeat the question.
Somebody noticed in your picture, it looks like there's something blue on top of the sound system, and it looks to me like it's just a bunch of cords and stuff, but they were wondering, what is that blue thing up there?
I'm not sure what blue thing you're talking about. Was it was it in my actual paper, or was it one?
It's on your profile. It's on your picture of you at the
at my studio.
Board. Yeah.
At the studio.
Yeah.
Let me just double check. Let me just at the studio. And with my profile picture, I'm not seeing a blue thing. So I'm not quite sure exactly what they're pointing to. What are they pointing to exactly?
It's at the top of your picture. It looks like some cords or something.
Yeah, I think they're just, yeah. Okay, I see what they're called. But yeah, they're just a bunch of cords. That's not my studio. That's the studio, the college radio station that I used to DJ for.
Well, you're getting some props in the studio. We have a $5 super chat from Mitchell. Says, for poops and chuckles, what came first, the chicken or the egg? For both.
Obviously the egg.
Obviously the chicken. Hey, next debate, David. What came first, chicken or the egg? And
yes,
I want to enjoy this conversation. I like your approach. I think you're respectful, and I noticed that in your Hovind debate. So keep up the good work, man.
Yeah, I try to be as respectful and cordial as possible. Nobody wants to listen to a debate where they're just saying, you're just a bunch of lying scumbags and berating them over the head of calling them a bunch of idiots. Nobody wants to listen to an hour of that.
Oh, I wouldn't say nobody. I'm just kidding. All right, next question. So Bill Shepard says, I have a question for SFT. How exactly is it that he professes to be a creationist while simultaneously holding to the insight view of Genesis chapter 6?
Yeah, you kind of cut out there, Converse, but I think I got the gist of the question. Yeah, I think see, when we take a literal approach to Genesis, for example, we can now look to science and we can make retrodictions, predictions, and it just so happens to turn out that we have scientific evidence for one mitochondrial DNA female ancestor, one Y chromosomal male ancestor, the fact that humans in general have low genetic diversity. I mean, these three factors point to common ancestors, two common ancestors, not just of a small population, but literally two, Adam and Eve. And we can go on and on regarding the genetic related evidence that does point to a literal interpretation of Genesis. So I think it's theological and scientific. So that's why.
All right, just a few more here. Eric Varenthaler, 92, says, hey, Converse, do you think that Standing for Truth and I could do a debate on Modern Day Debate sometime? Because Kent chickened out on my debate with him. The topic is, are birds dinosaurs?
I would love to see that debate.
What do you think, SFT?
Oh, I thought that was are birds dinosaurs?
He was asking, would you be willing to debate him sometime on that?
Yeah, that would be probably a topic that is not 100% of it. I mean, you know, I'd prefer more of a topic like David and I have debated. And if that's a topic Eric would like to debate, I'd be happy to. If he wants to debate the specific topic of our birds, dinosaurs, I would just probably take some time to prepare, make some notes, some slides, but sure.
Okay, perfect. All right, so we have a 5-part question. So I'll try and get through it all. It says, modern day debate, Nephilim-free, how do you explain the left recurrent laryngeal nerve found in humans? Then the next part of that is, this runs from the brain to the voice box, which is usually in the distant range of a few inches, but instead it goes all the way around, all the way down into the chest, loops around the main artery, and then goes back up to the voice box, which is present in the garage, and results in 15-foot detour. In animals without a neck, such as fish, the most direct route for the nerve is by navigating around the artery. And then the last part of that looks like, if mammals evolved from fish-like ancestors, we can easily explain this. Do you want to take a shot at that, SFT?
Sure. Yeah, I think that all comes down to the vestigial organ argument, for example, or the argument from bad design. But to make a long story short, since that would require a long answer, I was just looking at a couple articles on this, which I would post as well, where they go into great detail on why that recurrent laryngeal nerve is not poorly designed, as the evolutionists would say, but is rather evidence of both good and intelligent design. And they go through a number of reasons, really lengthy articles. So as an answer to that question, instead of going through all that or reading that off, I would just post that into the comment section afterwards.
All right, thanks so much for that. We have a quick question from Andrew T. Says, a real question for SFT is, has he ever published a paper?
Have I ever published a paper? No.
All right, thanks so much for that. Jeremy T says, standing for truth, the flu mutates every year, making it more resistant to our immune system. Those are mutations that give an advantage to the viruses over non-mutated flu viruses.
Yeah, viruses do mutate. They often mutate fast. And you can get different versions or variants of, for example, as you said, the flu virus quite quickly. That's why sometimes it's hard with the flu shots to get a shot, directly for the seasonal flu, because there could be many variations of it. But generally, just like antibiotic resistance and things like this, it's all typically evidence for reductions in information, loss of function mutations. So yeah, as I pointed out in the debate, the key issue is net gain versus net loss. So those types of changes are not going to take your fish to fisherman.
All right, thanks so much for that. Last question from TD Lane says, question for Standing for Truth. Do you know that radiometric dating cannot be applied to a very recent igneous rock because there hasn't been any time for decay?
Yeah, I think there's been a ton of evidence for rocks of known age that date millions and millions of years old. So why should we trust rocks of unknown age? And I believe there is plenty of physical evidence that rapid nuclear decay has occurred in the past. We discussed it a little bit in my last debate with Erica, but for example, byproducts of this radioactive decay would include helium, fission tracks, and radio halo. So that's observable evidence in the rocks that rapid decay has occurred. And there's a number of processes during the flood, like for example, meters per second plate movement in the catastrophic plate tectonics model. Runaway subduction can speed up the decay rate. It would produce a lot of heat, but there's also various mechanisms. And I know David asked this question to Hovind, and we could have a debate about that at some time in the future, but there's a various amounts of mechanisms that can get rid or reduce the heat. that is, that comes off from the catastrophic plate tectonics. So yeah, good question.
All right, thanks so much for that, and we'll end it there. So I just want to say thanks to both contenders for coming out. Say thanks to Praise for the behind-the-scenes hosting of this stream. Thanks, thanks for
Praise.
Yep, thanks to James for the channel in general, and everybody for checking it out. Please hit that like button on your way out, and subscribe if you haven't already, and consider becoming a Patreon member, like myself and others. And we got some really interesting discussions coming up, some cool debates. Kent Hovind will be back on, hopefully, fingers crossed, right? And I just want to say thanks again to both of the contenders here for sticking through all the questions. And if I missed your question, I'm sorry. I try to get to all of them that I've seen, but if I did miss it, I am genuinely sorry for that. So with that, thanks so much. And as always, keep sifting the reasonable from the unreasonable.
All right. Thank you guys so much. Once again, thank you, Standing for Truth. Thank you so much for this debate, and thank you guys. Thank you so much, Praise, for being here behind the scene work. Peace out, and I hope to see you guys soon.
All right, buddy. Thanks.
Awesome. Thanks again. Yeah, David, it was an engaging debate. I really enjoyed myself. Thanks for, like I said, thanks for moderating their converse, and I hope the audience had a good time. So thanks.